We're going to talk about the procedure of integration by parts today. You can see that this process is derived from the product rule. I have two functions, u and v, that are both differentiable functions of x, and I'm going to take the derivative with respect to x. I have the first times the derivative of the second, plus the second times the derivative of the first. You can see that here. I've just done some rearranging where I've taken this term that's circled here, and I've subtracted that term from both sides of this equation, and now I have the derivative with respect to x of the product u times v minus that quantity, v times the derivative of u with respect to x, and that's equal to u times the derivative of v with respect to x. Now I'm going to integrate both sides with respect to x, and you see the integral of u dv is going to equal to the integral of the derivative with respect to x of u times v, which that results in just u times v. The antiderivative of the derivative is just u times v, minus the integral v times the derivative of u. This procedure, again called integration by parts, is particularly useful for integrands involving products of different types of functions. And there is a mnemonic to help us determine which to choose for, which part of the expression to choose for u, and the remainder will be dv. The mnemonic is look for a logarithmic expression, inverse trig, polynomial, exponential, or trig in that particular order. So my first example is the integral of x, natural log of x, dx. Again, using that mnemonic, I will let u be the natural log of x, then du is 1 over x dx. If this is u, everything remaining, x dx, has got to be equal to dv. The antiderivative then of this expression, x dx, is x squared over 2. Now again, remember, the integration by parts is u times v minus the integral of v du. And we chose u as natural log of x, v is now x squared over 2, minus v, I'm going to put the 1/2 outside the integral, x squared dx, 1 over x dx. I've got x squared over 2 natural log of x minus 1/2 the integral of x dx, simplifying that expression, x squared over 2 natural log of x minus 1/2 x squared over 2 plus c, or x squared over 2 natural log of x minus x squared over 4 plus c.